This is the NMR spectrum of 1,1,2-trichloroethane. In the expanded spectrum, we see that the signal of the methylene protons is split into two peaks, a doublet, and that the signal of the methyne proton is split into three peaks, a triplet. This splitting of peaks into multiplets is caused by interaction between neighboring hydrogens called spin-spin coupling. No spin-spin coupling is observed between equivalent hydrogens, or hydrogens that are more than 3 bonds apart, except for certain pi systems, where long-range coupling can be observed. Generally, no coupling is observed for hydrogens attached to oxygen or nitrogen, except in very pure samples without traces of acid or base, where hydrogen exchange is slow. The cause of spin-spin coupling lies in the magnetic nature of the spinning hydrogens. Like little bar magnets, hydrogens on adjacent carbon atoms can sense the orientation of one another. Let's consider the case of 1,1,2-trichloroethane. If the spin of the methyne proton is aligned with the magnetic field, B0, then its magnetic moment adds to the magnetic field experienced by the methylene protons, which slightly increases their resonance frequency. If the spin of the methyne proton is opposed to B0, then its magnetic moment subtracts from the magnetic field experienced by the methylene protons, which slightly decreases their resonance frequency. The methyne spin can align either way, and two peaks are observed for the methylene protons. The methyne proton also senses the spin orientation of the methylene protons. Since there are two methylene protons, they can be both aligned, both opposed, or in two different ways can have one aligned, one opposed. These three different spin states each lead to a separate peak. Because the number of combinations for a spin state determines the height of its peak, the center peak is twice as intense as the side peaks. The number of peaks into which an NMR signal is split is predicted using the n+1 rule. Coupling to n equivalent hydrogens splits an NMR signal into n+1 peaks. In the case of bromoethane, the set of two methylene protons and the set of three methyl protons are coupled to one another. The NMR signal of the methyl protons is split by two methylene protons into three peaks. The NMR signal of the methylene protons is split by three methyl protons into four peaks.